You know, it's kind of wild to think about. The ground right under your feet. It feels so solid, so permanent, right? But what if I told you it's actually in a state of constant slow motion chaos? It's true. Our planet's surface is always moving, always reshaping our world in the most powerful ways imaginable. So let's get into the incredible story of plate tectonics.
So what is this incredible force? What's the hidden engine that can build up massive mountains, shake the very ground we live on, and even create brand new islands out of nothing? Well, it all comes down to one single beautiful theory: plate tectonics. This is the story of how our world rebuilds itself. And to really get it, we need to meet the main characters. And here they are, the tectonic plates. So picture this. The surface of the Earth isn't one solid, smooth ball. Nope. It's more like a giant, cracked eggshell, and it's broken up into these massive slabs of rock. These giant puzzle pieces that are constantly floating, shifting, and yeah, sometimes crashing into each other all across the globe.
Okay, so if these massive puzzle pieces are moving around, you gotta ask, what in the world are they moving on? To figure that out, we need to look a little deeper, just underneath those pieces.
All right, check this out. The plates themselves, our cracked eggshell, are part of what's called the lithosphere. That's the cold, brittle outer layer. But they float on the layer below, the asthenosphere. And this layer is totally different. It's hot and it's semi-fluid. Honestly, the best way to imagine it is a bunch of giant solid rafts floating on a sea of super thick, hot honey. And it's that gooey honey layer that lets the plates glide across the globe. And get this, they move at about the same speed your fingernails grow. I know it sounds slow, but over millions of years, that tiny movement changes absolutely everything.
So we've got these plates floating around. What happens when they actually interact with each other? Well, let's start with what happens when they move apart. And believe it or not, this is all about creation. This is where the Earth literally makes new ground.
This, my friends, is called a divergent boundary. The name kind of says it all, right? The plates are diverging. They are pulling away from each other. And when they do, they leave a huge gap right in the middle.
So what fills that gap? Nature hates a vacuum, right? Well, that hot, gooey stuff from the asthenosphere, magma, rises up to fill the space. It hits the cold water or air, cools down, hardens, and bam, you've got brand new rock. When this happens deep under the ocean, it creates these enormous underwater mountain ranges like the Mid-Atlantic Ridge. But when it happens on land, it can literally rip a continent in two, forming massive valleys like the East African Rift. This is how our planet's crust is born.
All right, so that's what happens when plates break up. But for every action, there's an equal and opposite reaction. If plates are separating over here, that means they have to be crashing into each other somewhere else. And this, folks, is where things get really, really dramatic.
We call this a convergent boundary. You've got two plates on a direct collision course. It's like a super slow-motion car crash that lasts for millions of years. But what happens next isn't always the same. It all depends on what kind of plates are colliding. And to get that, we need to talk about one super important process. And that process is called subduction. This is a big one, so let's really lock it in. Think of it like this. When two plates collide, the one that's denser, the one that's heavier for its size, loses the fight. It's forced to dive down, to sink underneath the less dense plate, and it gets pushed back into the hot mantle. Seriously, remember that word, subduction. It's basically the planet's recycling program for its own crust. So this all plays out in three main ways. First up, an ocean plate hits a continental plate. The ocean plate is way denser, so it subducts. As it sinks, it melts, and that molten rock bubbles up to create huge volcanic mountains, like the Andes. Okay, scenario two. Two continents collide. Neither plate wants to sink, so they have nowhere to go but up. They buckle, they fold, and they create the most massive mountain ranges on Earth, like the Himalayas. And finally, two ocean plates collide. Here, the older, colder, and therefore denser one subducts. This forms a super deep ocean trench and a chain of volcanic islands, just like Japan or the Aleutians.
Just to make this super clear, look at the difference here. The Himalayas, that's a crumple zone. Two continents smashing together and pushing rocks sky high. Not much subduction, not much melting, so very few volcanoes. The Andes, though, that's a melt zone. A whole plate is sinking down, melting, and feeding a long chain of active volcanoes. See? Two kinds of collisions, two totally different ways to build a mountain. Pretty cool, right?
Okay, so we've covered pulling apart and crashing together, but there's one more way these plates interact, and this one
This one isn't about creating or destroying land. It's all about tension, grinding, and then a sudden violent release. This is what we call a transform boundary, and here, the plates are just trying to scrape past each other horizontally. Think of it like two cars just grinding alongside each other. No new crust is made, none is destroyed.
But here's the crucial part. This movement is not smooth. The edges of these massive plates are jagged, so they get stuck on each other. They lock up, and the pressure just builds and builds and builds, sometimes for decades. And then, all at once, they slip. All that stored up energy is released in a split second, and that sudden jolt is an earthquake. The most famous example of this, of course, is the San Andreas Fault in California. It's a textbook example of a transform boundary at work.
So there you have it, the three main moves in the plate tectonics playbook: dividing, colliding, and sliding. Now let's just zoom out for a second and see how this all fits together in one big, beautiful, continuous cycle that shapes our entire planet.
It's actually a really elegant system. Step 1 is creation. New crust is born where plates pull apart. Step 2 is the journey. That crust then travels across the surface of the Earth for millions of years. And finally, step 3 is destruction, or maybe a better word is recycling, when that old crust gets recycled back into the mantle at subduction zones. Creation, movement, recycling. It's the ultimate planet-sized system, and it never, ever stops.
And the wildest part of all of this? It's happening right now. As you're listening to this, the continents are still drifting. This process never ended. It makes you wonder, doesn't it? The world map we all know is really just a snapshot in deep time. So what's next? What will our planet look like in another 100 million years? It's just an amazing reminder that our planet isn't some static rock in space. It's a living, breathing world, constantly reshaping itself from the inside out.